Okay, good morning, students, and welcome to today's session. So this is friction session number 2 for us. So last week we had started with the concept of friction, or the understanding of friction as a contact force between two surfaces that acts in such a way that it opposes slipping or tends to oppose slipping. So let's take a quick recap and then begin with a question. So we had discussed about friction as a tangential contact force. Tangential meaning parallel to the surface of contact. Okay. And it acts in such a way that it either opposes slipping or prevents slipping. Okay. Based on this, we had seen that there are two types of friction: static friction and kinetic friction. Generally denoted by the symbol small f. Ansh, friction is a continuation of Newton's laws of motion, but it is a different chapter because continuation in the sense that it's the same idea of Newton's second law with free body diagram application, but the whole application is divided into two sections. One is the application without the presence of friction, or where the surfaces are only smooth and frictionless. The second chapter is okay, Kanish, just give me a second. Okay, this is session number 3, then we will come to that. Okay, so yeah, so we had discussed about static friction and kinetic friction. So this is session number 3. Probably we'll come to that. Okay, so what we had seen about static friction is that it can take any value up to a certain maximum limit, and that maximum limit is this value. Okay, so greater than equal to 0, less than equal to this. So this is called the limiting friction. Whereas kinetic friction acts whenever there is slipping, and it has a fixed value of coefficient of kinetic friction into normal reaction. It is irrespective of whether the external force is acting or it is not acting, or its value is independent of the external force. Its value is a fixed value and it opposes slipping. Okay, so let's begin with an example question. Okay, I will send the notes. So second lecture, the notes are not sent in the group, is it? So I'll send it. Okay. So anyhow, let's start with this example. So this is a standard kind of situation which you've seen before. This is just a practice example. So we have a block of mass m at rest initially. Okay. Now this block is being pushed, or rather being pulled, with an external force which is acting like this at some kind of an angle with respect to the horizontal. So given that the mass of the block is 10 kilograms and acceleration due to gravity is 10 meters per second square, The coefficient of static friction is 0.6 and the coefficient of kinetic friction is 0.5. Okay, we have to find the acceleration of the block. Okay, and frictional force acting on it. If now we'll take two parts. The first part, the force we are applying is 50 newtons, but at an angle of 37 degrees to the horizontal. Second part, the force we are applying instead is 100 newtons, and it is at an angle of 53 degrees with respect to the horizontal. Okay, just try out this question, and I will send you the notes also of the last lecture in between. So please send me the answer for the acceleration and the frictional force for both the parts. Yes, Anmol, very good. That's correct. Tantresh, just check your calculations once more. Yes, Anmol, your answers are correct. Good. No, unfortunately, only Anmol's answer is correct so far. So let's discuss. Okay. So the method of making the free body diagram will be common for both the parts. Okay. So you divide your force F into two components. Horizontal component F cos theta. And the first part, this horizontal component will become 40 newtons. And this vertical component will be 30 newtons. Okay. So weight of the block being 100, you can see that the normal reaction will become how much? The normal reaction will be mg minus F sine theta. So in this case, it will be 70 newtons. Okay. So you can see that maximum friction is going to be how much? 0.6 into 70. So that is 42 newtons. So you can see that the maximum friction available is greater than F cos theta. So this will show that there is no slipping. So acceleration will be 0 and static friction equal to F cos theta. That means static friction equal to 40 newtons will act. So this is the answer. So this will be static friction acting here, which will balance the F cos theta component because there is enough friction available to prevent slipping. Yes, very good, Kanish. That's correct. But check the answer for the second part. Your first part is correct. A very similar thing you have to do for the second part, only the values are different. This is for the A part only, where the force is 50 newtons and the angle is 37 degrees. Now work it out for the second part, B part. No, sorry, Kanishk, your answer is correct. B part, Anmol, you have to check your answer. Kanishk, your answer is correct. The acceleration will be 5 meters per second square. Anmol, you have to check your answer for the second part. Okay. So try to work out the second part yourself, everybody. I'll just put up the answer for B part, then I'll put up the explanation. So the acceleration will come out to be 5 meters per second square in B part. And the friction acting will be kinetic and it will only be 10 newtons. Okay, so let's quickly go over this and finish this question. So now here we are applying the force of 100 newtons magnitude, but at an angle of 53 degrees to the horizontal. So the horizontal component of force F cos theta will this time become 60 newtons, whereas the vertical component, that will be 80 newtons. So that means the weight being 100 newtons, we have a very comparatively small amount of normal reaction. So the normal reaction is only 20 newtons here. Okay, so therefore maximum static friction available is 0.6 into 20. So that's only 12 newtons. So here you can see what is happening is the opposite, that F cos theta is greater than maximum static friction. So therefore the block slips. So if it slips, it means that the acceleration is non-zero, and the friction acting will be kinetic friction. Okay. So unlike the previous case, the friction acting here will be kinetic friction, which will be mu k into n, and this will create an acceleration like this. So now our equation for this will be F cos theta minus kinetic friction is ma. So F cos theta is 60. So this will be 60 minus 0.5 into from here. Sorry, from here, normal reaction. So this is the acceleration, and the friction acting on it is 10 newtons in magnitude. Okay, so hope this is clear to all of you. Okay, let's move on to a situation with inclined plane next. So we have an inclined plane like this, where this angle is 37 degrees, this angle is 53 degrees. And we have a fixed pulley over here. With a thread going around like this. So for both blocks, A and B, the coefficient of friction is 0.4 with respect to the surface, okay, the inclined surface. And mass of A is 60 kilograms, mass of B is 40 kilograms, G is equal to 10 meters per second square. So you have to find the acceleration of the blocks and the tension in the string. Okay, work this out quickly. Okay, so I'll just get you started on how to analyze this problem. So you can see that there's going to be a tendency to slip, because the coefficient of friction obviously is quite less. It's only 0.4. But the first thing you have to determine is what is the direction of slipping. So let's come to that. So whether the fact that block A is heavier, okay, 60 kg, that will dominate, or the fact that this is on a steeper slope, that will dominate. Okay, so let's understand that. And coefficient of friction is 0.4 for both of them. So let's take the components of weight. So this is going to be this much. So we'll work this out. So 600 into sine 37, so that's 0.6. So this will be 360 newtons. And this will be 480 newtons. Okay. So here the normal reaction will be 480 newtons. Okay. But first let's work out the components of this one's weight. This will be 320 newtons. So this will be 240 newtons. So the maximum friction available on this will also, we can determine by this. So we can see that this component dominates. So there's a tendency to slip like this. There's a tendency to slip like this. Okay. But we don't know if the slipping will actually occur or not, right? So you can see that maximum possible friction on A is how much now? And maximum friction on B, that's 30. That this pulling force is 360, this pulling force is 320. So the difference of these two forces is only 40 newtons, and the amount of friction is very large. So most likely what is going to happen here is that friction is going to prevent slipping. Okay, so let's understand how it's going to prevent slipping. So suppose there had been no friction, then the direction of slipping would have been like this. This is the tendency to slip. It would have been like this. So friction will oppose this tendency to slip. Okay. Okay, so this is a more tricky type of question in comparison. Okay, so these are the forces that will be acting within the system. So now see, for block A, assuming no slipping. Okay, so for block A, we'll have the equation that the weight sign component is balanced by friction plus tension. So we have 360 newtons is equal to friction on A plus tension. And we know that the maximum possible value of friction is this much. Okay. For block B, we have tension is balanced by weights sign component plus friction. So we have tension is equal to 320 newtons plus friction, where we know that the maximum friction available, so this is less than equal to 72 newtons, and this is less than equal to 36 newtons. This is the tendency we have. Okay. Now if we just, so this is assuming no slipping. Okay. Now if we just add the two equations, we'll get rid of tension, and you'll see that 360 is equal to 320 plus FA plus FB. So we'll see that the sum of the frictions acting on the two is going to be equal to 40 newtons. And we can see something that the maximum value of FA plus FB is 36 plus 72. So that's a huge amount of friction. So that means this is definitely happening. That means the assumption is correct. So therefore, assumption of no slipping is correct. Okay. And acceleration of the system will be 0. Anmol, where we got the limiting value of friction, the maximum friction. Okay, that's very simple. On the inclined plane, you can see a normal reaction. Normal reaction कितना होता है? It is equal to the weights cost component. Na? Okay. So normal reaction is equal to this. Therefore, maximum friction is equal to mu n. So it is mu mg cos theta. So this is a concept we have applied for calculating the limiting values of friction or the maximum values of friction. This value here and this value here. You can see the normal reaction on A is 480 newtons. The coefficient of friction is 0.4. So 480 into 0.4 will give you, oh sorry, the values are wrong. Yeah. Just a minute. The values here are probably wrong. Just let me check. So the maximum friction is 480 into 0.4. So that is going to be equal to how much now? Much more actually. You know? It's going to be 196 newtons. and this will be yeah. So this will be 96. Okay, but the analysis will still hold the same. Just need to adjust these values. Yeah, Anmol, it is clear now. You have got these values yourself also, right? Okay. Prince, is the concept clear now? Okay. Now see, coming back to equation 1 and 2, equation 1 and 2 are telling us that if the block should remain at rest, that is what friction's priority is. Now friction is trying to keep the system at rest. Then how much is the total amount of friction required? The total amount of friction required is only 40 newtons, whereas the total amount of friction available is much more than that. And the total amount of friction available to us is as much as 192 plus 96. So it's a much larger amount of friction available to us. It's 288 newtons of friction available, whereas only 40 newtons of combined friction is required. So definitely our assumption is correct, and the system will not be slipping. The acceleration will be 0. So is this clear over here? Okay. So ultimately, see what is happening. The difference of these two forces, 360 and 320, is 40 newtons. So that difference will be balanced by friction. So you can see here that these equations will be satisfied in such a way that the sum of the two frictions will be 40 newtons. Okay. And the acceleration of each of the blocks will be 0. So the final conclusion is this. Right, very good. So now let's, so these type of problems you're confident with. Now we'll move on to the two block type of problems. But before that, I also want to discuss one which has constraint relation incorporated into friction, system of pulleys and constraint relation. So let's quickly look at that kind of example also. So all the concepts we've learned in Newton's laws of motion, they're going to be important in this chapter also, like pseudo force concept, then constraint relation for system of pulleys concept. But in addition to that, we have to also incorporate the frictional force. So that is why I said that this is not like a new part of the syllabus. It is continuation of Newton's laws. It's just that to the analysis of Newton's second law, we have to now add the force of friction also. So it's really part of the same chapter, application of Newton's laws of motion. Okay, so we have this kind of a system now. So this is a fixed pulley to this surface, whereas this pulley is fixed to this other block. So both the pulleys are massless. They are smooth and massless. Now, given that mass of the block A is 40 kgs and the coefficient of friction on that surface is 0.5. So first thing, find the maximum possible mass of B such that A does not slip when the system is released. Okay. And secondly, if the mass of B, instead of this maximum value which you calculated in the first part, if the mass of B is 100 kg, then find acceleration of A and acceleration of B. So when you do the first part, you'll understand that in the second part, because the mass is 100 kg, the system will definitely accelerate. So now you have to find out how much that acceleration is. So just work this question out quickly. Okay, so I'm verifying the answer of the first part for all of you. So A part's answer, or the first part's answer, sorry, mass of B should be less than equal to 40 kg for A not to slip. Okay. So let's understand how this is happening. So if we assume here that the system is at rest, then our free body diagram will look like this. Okay. Assuming no slipping, so acceleration of A is 0, acceleration of B is also 0. So weight of B is balanced by 2T. That's the first thing. Okay. Whereas when it comes to A, static friction has to balance the weight. Sorry, has to balance the tension. Okay. And also normal reaction balances the weight, which is, how much is the weight of A now? Yeah, 40 kg. So 400 newtons. Okay, so this is the situation for no slipping. Okay, now maximum friction is mu into n. So this, okay. So therefore, from equation 2, tension should be less than equal to maximum friction for acceleration of A to be 0. So tension should be less than equal to 200 newtons. So now substitute this in equation 1. So this thing should become less than equal to 400 newtons. Therefore, mass of B should be less than equal to 40 kg. So this is the simple solution to the first part. So obviously you can see in the second part, when I increase the mass of B to 100 kg, there will be acceleration. Okay, and now you have to apply the constraint relation. So the constraint relation is that acceleration of A and B will be in the ratio 2:1. Acceleration of A will be double of acceleration of B, and the friction acting on A will be kinetic friction. So it will be mu into N. So hope this part is clear to all of you. Now let's come to the second part. So in the second part, now we are taking the mass of the block B to be 100 kgs. So definitely the system will have acceleration. Rest of the things are same. Mass of A is 40 kg. Coefficient of friction is 0.5. Okay. So now let us consider the situation So this is going to be 1000 newtons. So definitely we will see that the system will have acceleration. Now, first of all, acceleration of A will be twice of acceleration of B. This is constraint relation. You can either use thread length concept or virtual power method. Yeah, Prince, I'll take you back to that part later. Okay. So if this acceleration is A, this acceleration should be double of that. Okay. And then the second thing here is that the friction acting, this will be kinetic friction. So for the block B, we'll have the equation weight minus 2t is mass into acceleration. So on substitution, this will become 1000 newtons minus 2t is going to be mass of B, which is 100 kg, into acceleration, which will take as this A. Okay. For A, we will have the equation that normal reaction is equal to weight, which is equal to 400 newtons. Okay. And tension minus kinetic friction is mass into acceleration. Sorry, acceleration of A. So acceleration of A, remember, we'll substitute as 2A. So tension minus mu into N is going to be mass of A into 2A. So when we substitute this value, this will be, okay. So mass of A was 40 kg into 2A. So this equation will become T minus 200 is equal to 80A. Okay. So now we have to solve equation 1 and 2. So solving 1 and 2, what we can do is we have this equation and we can multiply this with 2. It is equation 2 multiplied with 2 on both the sides. And then we can add these two. So 2t cancels out. So we have 1000 minus 400 is equal to 100 plus 160 A. So we have A is equal to 600 by 260. So A is equal to, okay. So finally what we'll get is acceleration of B will be 30 by 13 meters per second square downwards, and acceleration of A will be 60 by 13 because it's twice of A horizontally like this. Okay. So this becomes our final answer set. Okay, so just note this down and I'll take you back to the first part also, Prince. Yes, so Tantresh, your answer was correct. Very good. Okay, Prince, you can just take down the last part of this. Okay, so done with this, Prince. Okay, good. Okay, now we come to an extremely important type of question. Based on friction. So these are generally called the two block problems. So last time we had seen a situation where two blocks were placed one on top of the other, but that was a situation where the ground was rough and between the two blocks there was no friction. Okay. Now here is going to be opposite. The floor on which the heavier block is kept, that is going to be a smooth floor, but there is friction between the two blocks. Okay. So that's what makes these type of problems more interesting. So this is a smooth surface. Okay, but this is a rough surface and it has coefficient of friction mu, and this block is A and this block is B. So the system is initially at rest. Okay, and given to us that the mass of the block A is 5 kilograms and the mass of the block B is suppose 10 kilograms. Okay, now what we do is we start pushing the lower block, that is B, with a horizontal external force like this. So now a horizontal force F is applied on B. Okay, and it is observed that A and B, okay, start to move at an acceleration of 2 meters per second square. That is, there is no slipping between the two blocks A and B. Okay, that is, they move together as one block, that kind of thing. Okay, so what we have to do here is make free body diagrams of A and B to find out the frictional force in the system, the magnitude of F, and C, the minimum value of mu for this situation. What is the minimum coefficient of friction mu that is required? The ground is smooth, remember. Okay. Just take down the data of the question first, then I'll explain how we will approach this question. Okay, so let's understand what's happening here. So what we are observing is that on application of this force, okay, this whole system starts to accelerate with a common acceleration of 2 meters per second square. There is no slipping between A and B. Okay. And of course, all this data is given to us that mass of A is 5 kg, mass of B is 10 kg. Okay. Okay, Prince, write down quickly. Okay, so don't worry about the statement of the question. Just write down the data, then I'm coming to it. Yes, done, Prince. Okay, so right, let's move on. So now let's understand the first thing, the free body diagrams of the individual blocks. Okay. So this is where you'll have to understand the tendency of slipping. So when we are pushing the block B, okay, what is happening? The block B will definitely, have a tendency to move towards the right. So in terms of block A, it is having a tendency of slipping towards the right. So A will apply a friction on block B, which will be like this. Because with respect to A, B has a tendency to slide forward. Suppose there had been no friction between them, then B would have just slid forward and A would have remained stationary. So the tendency to slip for B with respect to A is towards the right. So the friction that A applies on B is towards the left. Okay. So accordingly, when you look at A's free body diagram, it will be applying an equal and opposite friction like this. This is action reaction pair. The friction that B applies on A is forwards, and the friction that A applies on B is equal and opposite backwards. Okay. And apart from that, of course, you have the vertical forces, which is this weight, this normal reaction. Okay. Then normal reaction acts on B also. So A is applying a downward normal reaction on B like this. Of course, B has its own weight. The ground is applying an upward normal reaction on B. And most importantly, both are having the common acceleration of 2 meters per second square given to us. Okay. So from this, what we can see from A's free body diagram, we can analyze that the friction acting on A is mass of A into that acceleration. So that is equal to 5 into 2, 10 newtons. Whereas the normal reaction acting on A is equal to its weight. So that is equal to 50 newtons. Okay. Whereas for B, we can see that F minus friction is mass into acceleration. So that will tell us that F minus friction is equal to 20 newtons because its mass was 10 kg. And normal reaction on B is equal to normal reaction due to A plus the weight of. So normal reaction on B will become 50 plus 100. So 150 newtons. Okay. So these are the important equations here. These two are the most important equations for us. So straight away you can see the answer to the first thing, that the friction acting between them is equal to 10 newtons. Okay. And substitute this over here. From this equation we'll get F minus 10 is equal to 20. So the force we are applying is 30 newtons. The external force we are applying is 30 newtons. Okay. And we can also see that this friction is less than equal to mu into normal reaction acting on E. Okay. So the important thing here is that this friction, this is a static friction. Why it is a static friction is because there is no slipping between the surfaces of A and B in contact. It's acting between two surfaces which are not slipping with respect to each other. So this is a static friction. So because it is a static friction, it need not be equal to mu n. It can be less than mu n also. So this 10 newtons is less than equal to mu into normal reaction on A, which is 50 newtons. So that means mu is greater than equal to 1 by 50, I mean 1 by 5 or 0.2. So the minimum coefficient of friction here is 0.2. It can be anything from 0.2 to larger. So these are the things we wanted to calculate. We wanted to calculate the friction between A and B, the amount of external force we are applying in newtons, and the minimum value of mu for this situation. Okay. So here is the answer to each of these. This is the friction, this is the force we are applying, and this is the minimum coefficient of friction, 0.2. Okay, so very critical question. Make sure this is clear to you. Let me know if there's any doubt for any of the equations that we've written or the free body diagrams that we've made. Okay. So all these free body diagrams are in ground frame. They are with respect to inertial frame or ground frame. Okay, so hope this question is clear, people. Now next we will see another sort of part of this question with a different set of data given with the same kind of situation. So that means we again have the combination of two blocks on a smooth surface rather. But this time what is given to us is the coefficient of friction between the blocks, okay, and the amount of force we are applying. So this is a smooth surface, whereas this is a rough surface, which has a coefficient of friction mu. And initially the system is at rest, but we start moving it by applying a force like this. Okay. So the data of the question is the same. Mass of the block A is 5 kilograms. Mass of the block B is 10 kilograms. But this time coefficient of friction is given to us as 0.25. So we want to find the accelerations of A and B if, first of all, the force we are applying is, let us say, 30 newtons. Oh, sorry, 30 we had taken in the last case. So let's take something different. So let's say we are applying a force of 15 newtons. In the second case, we are applying a force of 45 newtons. The system was initially at rest. Okay. So just start with the first part, make the free body diagrams and see what we can analyze here. Take G as 10 meters per second square only. Okay, so see, the first thing we should try and understand here is that what is friction's priority? Okay, friction's priority is to prevent slipping between blocks A and B. Okay, so friction will try to prevent slipping between A and B. So therefore, the acceleration of block A should be equal to the acceleration of block B if there is no slipping. Okay, but what is the maximum friction available? That is going to be equal to mu into normal reaction on A. Okay, because the surface of contact between A and B, the normal reaction at the surface of contact is equal to the NA. So the friction is going to depend on that. Okay, so it is going to be mu times weight of A, because NA is equal to weight of A. So the maximum friction available to us is going to be 0.25, that is a coefficient of friction, into weight of A, which is 50 newtons. So 12.5 newtons. That is the maximum friction available. But what is friction trying to do? It is trying to do this. It's not trying to bring the block to rest. It's trying to do this. Okay. So for the first part, when we apply the force of 15 newtons, okay, if we assume no slipping, okay, that is the friction acting is static friction. So it is less than equal to mu n. So this friction should be less than equal to 12.5 newtons. But more importantly, acceleration of A should be equal to acceleration of B. So that is equal to A, suppose. So what will my free body diagram look like? Now I'm showing only the horizontal forces because vertical forces I've already taken care of. Okay, so this should be static friction, this should be static friction, and they should have the common magnitude of acceleration, A. So both the blocks should be moving with an acceleration A, the ground frame, okay? So solving these equations, we'll see that acceleration is 1 meter per second square and the friction needed is 5 newtons. Now, because the friction needed is only 5 newtons, whereas the maximum friction available is up to 12.5 newtons. So therefore, we can see our assumption is correct, that there will be no slipping. Okay. So since a static friction of only 5 newtons is needed to prevent slipping between the blocks, when F is 15 newtons, therefore acceleration of A will be equal to acceleration of B, will be equal to 1 meter per second square, and static friction of 5 newtons will act. Okay, so hope this part is clear, people. If you also think in context of the previous question we did, you'll understand this even better. Okay, let's work out the second part. So in the second part, when we increase the force to 45 newtons, okay, now again we'll see what happens is that if we assume no slipping, that is acceleration of A to be equal to acceleration of B, that is equal to A suppose, and static friction, so that should be less than equal to static friction's limiting value was how much? 12.5 newtons. Okay. Now we assume that here again our free body diagram set will be like this, and both should have the common acceleration of E. So we should get so this equation is this, but we should get here F minus static friction is mass of B into A. So this second equation now becomes 45 minus whatever static friction is 10A. So now when we solve this set of equations, solving this, we will get acceleration as 3 meters per second square, but we'll get static friction as 15 newtons. Okay. Now the moment we see static friction is 15 newtons, we see that this is not possible because the maximum friction, okay, is only 12.5 newtons. So what we are seeing here is that to prevent slipping, okay, the static friction needed is too much compared to what is available. Is 15 newtons when the external force was 45 newtons. Okay, but this is not possible. But available maximum friction is only 12.5 newtons. Okay, so therefore friction cannot prevent slipping. So if friction cannot prevent slipping, what will happen is that acceleration of A will not be equal to acceleration of B. They'll have different values of acceleration, and kinetic friction will act. Okay. So this assumption is failing now that they have common acceleration. Instead, they will have different acceleration. And kinetic friction will act in the diagram. Okay. So as a result of that, our free body diagram will change now. Okay. In our free body diagram, they will have different accelerations. And the friction acting between them will be kinetic friction. So a new set of equations will become so 12.5 newtons will become 5 times acceleration of A. And for this one, we'll have F minus kinetic friction will be this. Okay. So 45 minus 12.5 will become 10 times the acceleration of B. So now from equation 1 and 2, we will get the individual accelerations. So from equation 1, acceleration of A we will see will be 2.5 meters per second square, and from equation 2, acceleration of B we will see will become 45 minus 12.5. So that is how much now? That is 32.5. So divided by 10. So 3.25 meters per second square. So they will have different accelerations. So there is slipping between them, because acceleration of B is becoming more than acceleration of A. So B is slipping from under A because we are applying too much force. Friction is not able to catch up with the extra amount of force we are applying. So the block B is slipping from under block A. It has a larger acceleration. Okay. So hope this is clear. With this, we'll conclude today's session. So please let me know if there's any doubt with the solving of this part, and otherwise wish you all the best. That's it for today's session. Also wish you all a very happy new year in advance. Okay. And sincerely hope for all of you that 2021 brings you a better year, a lot of success. Okay. And you are able to put in good efforts and get good results this year, because the effort that you put in 2021 will finally give you the most important result of your life in 2022 and then eventually in 23, when you get into first year and all that. So very important year of your life. A lot of your professional life from here on, what you are going to do in BTech after completing 12th, and from there on what you're going to do in your professional life, that depends on the year 2021. So very important for you. Wish you all the best and happy new year.